Moving right along then, Atlantic Ocean circulation. We've already seen many of the currents, so this is showing in detail how complex things actually get in the real world, other than just the Gulf Stream and the North Atlantic current and so on and so forth. You can think of it as if the analogy of the leaves always moving. The ocean always has things moving, as we will see. The perpetual ocean in motion creates all these recycling regions, and this figure here is showing the transports involved in the North Equatorial Current, Gulf Stream, North Atlantic Current, Canary Current, and South Equatorial Current, Atlantic Equatorial Counter Current, and so on and so forth, right? So the numbers shown on here, which you can read, I hope, 5, 3, 8, 5, 4, and so on, they are the number of Sverdrups million cubic meters per second being carried by the currents, right? So this western boundary current here, the North Brazil current, meanders around, splits, comes back and joins up. And the main feature to look for here is that you have these chain of islands, the Caribbean islands, which actually split the current that's coming north, and the gyre is hardly as simple as we had sketched so far. Okay, so the current becomes the Antilles current and the Caribbean current that goes into the Gulf of Mexico. Gulf of Mexico, as you may know, is a very, very warm gulf. It's almost tropical, with tropical corals going all the way that far. And this flow between Cuba and Florida carries a lot of water, 30 to 60 Sverdrups. You can see the number there, 30 Sverdrup, that's a lot of water. So things can drift right along, including people who are sitting in dinghies and rafts and so on. So the main point here is that you have the Canary Current, which is made up of multiple components. You have North Equatorial Current, which is a mixture of multiple components, and the gyre itself, while very well defined, has multiple breaking up of the currents and rejoining of the currents and so on. But Gulf Stream remains very coherent, and it carries a lot of water. Its basic transport is about 30 Sverdrups, but because of these recirculations bringing more water, it can add up to almost 100 Sverdrups. And remember again, Amazon is only 0.2 Sverdrup. So you have a lot of water streaming right along the coast. As we said, it's warm water bringing heat all the way from the tropics into these North Atlantic open ocean regions. North Atlantic is very narrow compared to the Pacific, which is very vast. And this makes a huge difference, right? When you bring these warm North Atlantic current from the extension of the Gulf Stream, the atmosphere is very cold at these latitudes, right? And you bring very warm ocean below it. What's going to happen? It's going to start creating a lot of evaporation. Okay, so what did we say happens with evaporation? You're breaking the hydrogen bonds and taking energy out of the ocean. So you're cooling the ocean, plus you're leaving the salt behind, which means you're going to create denser water if you have a lot of evaporation. This is a region which is unique for that matter, that Gulf Stream is able to bring in a lot of warm waters and create huge evaporation and create dense water that sinks like a rock, and it's called the North Atlantic deep water. Okay, and you can see that that current continues off into these Norwegian seas. So this region called the Jin Sea, Greenland, Iceland, Norwegian Sea, is where the Gulf Stream and the North Atlantic current continue to drift off and make various recirculations. So this region is very important because if you change the density of this region by increasing evaporation or reducing evaporation, you will change this sinking of the water, which will take heat with it, which will take greenhouse gases with it, and so on. How can you reduce evaporation? Basically, you can make it colder or you can make it fresher. So even if there is evaporation, if the water is fresh, then it will not be able to form so much deep water, right? So there have been examples in the past where a lot of fresh water got released from these land lakes in Canada. Greenland glacier is melting a lot right now, so that could release a lot of fresh water. That won't reduce the evaporation, other than that if it cools the temperatures, then the evaporation is exponentially dependent on sea surface temperature and air temperature, so that's going to make a difference. And you might have seen this movie called Day After Tomorrow, where in the beginning some people are reporting very warm temperatures of Greenland, and before you know it, New York City is freezing. We will see how this scenario actually may play out. Not as fast as it happened in the movie, but nonetheless, this region, the Jin Seas, Greenland, Iceland, Norwegian Seas, a very important, critical, sensitive region for the thermohaline circulation, North Atlantic deep water formation, heat uptake by the ocean, and modulation of the global warming. Okay, we will see that in more detail as we go along, and I will stop this podcast here just so that you can absorb the concept. It just extended the western boundary concept into something else. Okay, we will see a few more things that happen because of this in a minute.